All right, in tonight's tutorial, I've prepared for this tutorial for a very long time, for about 2 months, trying to figure out how to detect the BPM of a song. So this is what I'm gonna show you how I did here. This is the end result. So what happens here is I have some different songs or some beat loops, and this is a beat loop right here, and the waveform was analyzed somewhat so that, I don't know if you can hear that, so that I could find where the beats are. Okay, so let me just press play on that again. So the yellow line is the actual waveform. Let me hide the other two lines here, like the peak line and the simple line. This is the waveform, and this, as you can see, like when I look at it with my eyes, I know this is the drum, this is the snare. Somewhere in here is the drum, this is the snare, this is the drum, the snare, the drum, and maybe that's a snare again. But this is 120 beats per minute, and the BPM detection I did detected it at 121 beats per minute. Also, if I press play, I could tap out the beat. And you can see I got the same thing. So in this wave file, this beat detection worked just fine. So let's go over how I did this. I'm going to start over another Unity project from scratch. So let me just close this project out, and I'll open up a new Unity project right here from Unity Hub. And I'll just call this one Beat Tutorial. Beat Tutorial. Okay. And it's going to be a 3D project, and I'll just say create. Hi everybody. In this Unity tutorial, it's going to be the first of maybe about 3 or 4 tutorials where I'm going to go over my results from trying to do beat detection in Unity. So let's call this the beat tutorial. Okay, and I'm going to create a brand new 3D project. All right, so we have a brand new project here, a brand new Unity 3D project. And the first thing I'm going to do is I'm going to add an empty game object to hold my song in. And I'm going to call it song. So this empty game object is located at 0, 0, 0. And let's see the axis here. I'm just going to hold down the Alt key and press the left mouse button to turn it around. All right, and face that way. Now under song, I'm going to add another game object. I'm going to add a cube, which is going to just be the base of my waveform that I'm going to display. And I will just call this bottom. Okay. And the bottom, I'll stretch out to maybe like 100 right now, just to get a, an idea of the size here for the wave that's going to display on. Then I'm going to make another empty game object, and this is going to be called start. And what the start is going to do is, so say I load a wave that's like, say this is like 1 minute long, then the wave, this bar would become 1 minute long, enough to hold the wave 1 minute long, and then I'd move the start position to the start of the bottom bar. Okay, since the this visual thing, its center is here, I just want to have a start that starts at the beginning of the bar, so I'm going to have a start for that. And under start, to display the waveform, I'm going to use a line. So here I will create a line, and I could set the width to probably like a 1 better. And the color, let me just make it yellow. Okay. I'll just make the line yellow. So I'll just move that all the way over and press accept. So there's a line here. Probably what I want to do is move the bottom down a little bit by -1, and then you can see a little bit of the line there, this tiny little line. And this is going to be the line that I'm going to draw the waveform with. And also here at the start, I'm going to create another empty. Now the reason I keep using empty game objects is because when I scale and move them, the child objects, I could have them have their own scale and movement. So I'm going to have a cursor that will move along the white line to say where in the song I am up to. And for us to see the thing moving along that white line, I will add another cube. And this also could be at -1. And I could just make it a little bit bigger than the bottom line, like 1.5 maybe. And I'll probably, or maybe like 3, something a little bigger so we could see it when it moves along the way. And also to see it move along the way, let's call this a pause. I'll just change its color. So I'll create a material, and this will be the pause material. So I'll just change it to red so it stands out. And let's put that as the material for the pause that shows the position. All right, so let's start off with this. And the other thing, we're gonna like zoom into the position, and as this moves, we want the camera to move with it. So I'll make the camera also a child of the cursor. And I'll just call it camera. Okay. There we go. So we have the song. This is like my position setup for like the waveform and the playback. Now, let's make this a little fatter on the Z scale for the position thing so it doesn't conflict with the bottom. So I'll just make it a little fatter, like 2. Okay. Or it could be 3, just like the other thing. There we go. All right, I got my game objects. I have a pause. I'm going to need a waveform to actually play back. So I'm going to use this one here. This is 120 beats a minute, a little sample loop. And just to make sure it works with real songs, I'll have a real song in here. That's a whole full song. And also, it's still coming in, right? Where are you? Did you come in? Oh, there you go. And then I'll also, these are stereo tracks. You see how they have a left and a right? I'll also make sure that this plays back with a mono track. So this thing that's 140 beats per minute is just a mono track, 1 track. All right, now for the busy work. Now that we have our objects, they're not going to do anything really until I have a script. So I'm going to create a C# script, and this is where the work will begin. I will call it song, and let's open up the song. Okay, so this is what we have by default. We just shell this thing out. There's some using statements I want to add up here. Using system.link. What I'm going to use is link lambda expressions. Since the waveform has a lot of data, there's like basically almost like 10,000 samples per second. Those are a bunch of numbers. I'm going to use link to query the data. And then I want to use system.io possibly to output what the data looks like to a file so I can read it. Okay, so I'm just going to add those 2 using statements there. Now in my class, I'm always going to add my little region area for helper things. 1, 2, 3, helper and region. So I'll have some helper data structures for myself. And let's see, this class, when I drag and drop it onto the song, I'm going to need an audio source that's going to have to be a component. So here I will just make sure that we do have an audio source when I drag and drop. So I'll say require component, spell that, type of audio source. And this makes it so when I drag and drop the script onto a game object that it'll add an audio source component if it's not already there. All right, so public variables that I'm going to expose in the script, samples per second. This is just going to be an integer actually, and you know, in a waveform, there's many samples. There's like hundreds of thousands of samples. But my human eye is not going to really be able to decipher between them all. So I'm going to group up samples to display at each point on this line and display like every 1,000 samples, average them out together and display a point. So how many I average together, that's samples per second. And I guess I'll start off with 1,024 samples per second. And the other thing, the sample values that are in the wave file or the song, sorry, they are values usually from -1 to 1. They're like really small, but I want them to display here larger than that so I could actually see them. So I'll just have like a thing to scale up the sample sizes. So I'll call that meter scale, and by default, let's see what it looks like at 100. And then the other thing, I'm going to have the camera here attached to the waveform, but you know, we may want to zoom out and zoom in. So we'll have a zoom factor, like how fast the zoom goes. So I'll call that zoom. And for starters, I'll just say a factor of 1. All right, and we'll see if we need to change that for anything. What else do I need? An audio source. Default it. And I'll need... All right, so say we got these things and we got the audio source. Now private void start. I want to actually see some code run. I'll say audio source to aud equals this dot get component audio source. All right, and then we'll just say like aud play. We'll just see if that works to start off with. So the script right now, it should just add an audio source component, and if I run it, it should play the sound. So let's go back here, select the song object, the song game object, the parent, and drag and drop song onto the song object. And here's the script, and it did add the audio source component. I'm going to tick off play on awake. And now I'm going to drag and drop an audio source here to have, so we have a song to play. And these things are set. If I press play, all I'm expecting right now is that I'm going to hear sound. So I'm going to press play. And you guys could hear it. Good. Now, with the audio source that I loaded, I want to actually display it. So let's do some things for that. So to display the waveform, I'm first going to make some helper things here, like a class called point data. And this is going to hold the information I need to display a point of my waveform. So I'm going to have the index, like which index this is. This is an int idx, initialize it. I'll have the time of this sample. This is a float in seconds, time, initialize. And then I will have the, since I said I'm summing up samples, you know what the samples per second, I'll have a storage of what the start sample is. And then I'll have a storage of what the end sample is for this. And then I'm going to have actually what is the value. So what's the sample value? Okay. And that, I'm just going to initialize it to 0. And then I have a value, but when I'm going to display it in the game, in the scene, I'll need a vector 3 for a position. So I'll say public vector 3. Okay. And then that vector 3 will be all the points of the sample wave going up and down, up and down. Let's see, that will be there. So that's for every point, and a song is made up of a bunch of points, so I will make a structure to hold everything about the song. I'll call it song data. This is just a structure. And public float all the samples from the song, I'll store them in there. Then I'll have to have my array of points for the song, and I'll use a list, point data, point, okay. And I want to know what my current point is when I'm playing back the song, like to hold the current position. So CP for current point. All right, that's good. So here I could add private song data. I'll just call it song. Okay, and then in the start, why is this red underlying? Cannot be the same as their enclosing type. Song data. Song class with a lowercase s. Oh, all right, let me just make this a uppercase s for the file. And then the file is a lowercase s. Let me just change that to file, save song as with a capital S. Save, does that work? Still looks lowercase here. Let me rename it. Song. And then let's see it in the script. Capital S, song, song. Yeah, but I guess this is kind of messed up. I'll just call this data. Data, okay, instead. The song data, I'll just call it data. So now our data dot samples, how many samples, how big does that float array have to be to hold all the samples of the song? Well, aud.clip dot, is it clip get data? Clip dot get data is going to be our function that gets all the sample data, and it takes a float and an offset. So our float is going to be our song samples, data samples, comma, and the offset we're going to start from 0. Now we just have to allocate that data samples array. So data.samples dot equals new float, and I'm pretty sure that the audio component tells us how many samples this is. So samples, no, audio.clip.samples, that's how many samples there are, but then we also have to multiply that by how many channels there are, clip.channels. If there's a stereo, there's a left and a right. If there's a mono, then that's a 1. So that should give us how many samples we need, and then this should get the samples into the array. Dang, I want to call this song, sorry. Song, there, song, song, song. So the song samples. Okay, now, boom, 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 boom. Let's just not play the music until the end of everything getting set up. So let me cut that and put it down here. Okay, song samples, you get them over here. Now we're gonna have to loop through all the samples in here. So for int, I'll call it s equals the first sample all the way to s is less than song.samples.length. And then s is going to increment on every loop by the samples per second. Okay, so that means in this loop I'm going to have to add up all the sample values. So let me have a variable to hold the sample values, sum. So first sum will equal 0, and then for int I equals 0 to I less than, well, actually it's not 0. We have to figure out what the start sample and the end sample is. So let's say song dot, oh no, what we're doing is a point data, because the here's the samples, and the point data is going to represent samples grouped up and averaged together. So we're going to make a point data, PD equals new point data. Okay, so pd.idx, which one is this? Let's have something that holds the count, int count, and it starts at 0. So this one's going to equal count. And then after we have it equal the count, then we're going to add 1 to it. So that's what this little thing plus plus symbolizes, that pdx will equal count, which is 0. And then right after we set that equal to 0, since the plus plus is on this side, count will increment. Okay, and then PD dot, what else did we have in our PD, our point data? We have the time. What time is this going to be? What value? What vector 3? So let's figure out what the start sample is going to be. Samples, no, it's going to be pd.idx times start times samples per second. Okay, so that's where we're starting. Ooh, that's where we're starting. Just thinking. That's where we're starting. And then, oh, I said samples per second. This is actually, let's name it better. Samples per point. Okay, because we got each point. So samples per point. So that's the starting sample, and then therefore the ending sample is going to be pd.idx plus 1 times samples per point, and then take that whole value and then just subtract 1. Okay, since we'll leave the actual, that's where the next one starts. So you subtract 1, and this is where this point's data ends. And now with the samples, can I get the time from the samples? PD dot time is going to equal PD dot, I'm going to have it equal the start sample divided by audio.clip.channels. Okay. Because basically right here, this get data, what it does is if this is a stereo audio source, then it puts the left, right sample, left, right sample. You know, you get the samples back like this. You get the left value, then the right, left and the right, left and the right. It keeps going like that to get the whole thing if it's stereo. Okay. But if it's not stereo, if it's a mono track, then it's just going to be, well, just say left, 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 left. Okay, so over here, I'll say the start, whatever the start sample is, divided by the audio clip channel, and then how many samples per second are in this audio clip. So audio clip dot frequency, that says how many times the actual sound was sampled per second. So if I just do this little math here, that should give me the time, the seconds. I just want to make sure that's a float over here. And the channels, I want that to be a float. Is that a float? Nope, it's an int. Okay, so everywhere I'm doing the division, I want to make sure I have a float so the time comes out accurately. Okay, so this integer divided by that, 1 or 2, and this one divided by that. Okay, and then that should give me an actual time in seconds. So what else do I have in my points? I have ding, 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 ding. Now I need the value. So for the value, I'm going to have to do some math. Let me initialize sum up here so it could stop squiggly underlining me. So first I'll start off that the sum is 0, and then I'm going to have a loop for int I equals pd.start sample, pd.start. Why doesn't know what PD is? Oh, you know why? Because I just jumped out the loop. Sorry, guys. Pay attention to where those brackets are. In here, I'll say sum equals 0, and then for int I equals 0 to I less than, no, not 0, equals pd.start sample until I is less than or equal to pd.end sample I plus plus. Is it plus plus? Is it plus plus? I think it'll be plus plus. Well, it's plus equal audio.clip.channels. Right? So if it's mono, it's like bing, 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 bing. If it's a stereo, then it's like bing, bong, bing, bong, bing, bong. All right, so I'm going to go like this. All right, so now in here, basically, wait a minute. Let me do this. If audio.clip.channels equals 1, then I'll do a for loop like this. Else, it's stereo. All right, so here I go. Cut, paste. There's one loop there. This could be plus 1, 1, 1, 1, 1. And then this one is going to be with audio channels. So for each channel, I'll say sum plus equals song.samples at I. Okay, that's that one. Down here, it's going to be sum plus equals song.samples at I plus song.samples at I plus 1. Whew. And then I have to divide by 2, or I could multiply, which is faster than division for the computer. Whew. Times 0.5. Okay. Man. Okay, boom, that's 1. This is 2. And the only other thing is, as we're going through this loop over here, start to end sample, I don't want to go past the length. So I'll just add in an if I is greater than song.samples.length, then, we'll just break out of the loop. And over here again, if I is greater than song.samples.length, then we will break out of the loop here too. Okay. So anyway, this part here, it's going to gather up the sum of all the values. And then what I do with the sum, okay, so this one's mono, and this one's stereo. Okay, adding up the values. Then after I get all the values, they're in the value of sum. Now my pd.val could equal sum divided by samples per point. Okay, and then take that value, which is going to be kind of small, and multiply it by our meter scale so we could see it better on the screen. Okay, so now we got our value. Now we can make our vector 3 so we could render it in a position in the scene, and that will equal a new vector 3. So it's pd.idx, that's how far along the x, and how high will it be? pd.val, and z position is 0. So that's our new vector 3. So up to this point, we made our new point data. Now we just have to add it to our point data array in the song. So last thing, don't forget this, song.point.add pd. Okay, now we got a list of points. Whew. Okay, so we took the song samples, we grouped them up in the points, we got a list of points. We should display this now on the screen. So, breathe deep, Omar. Breathe deep. I'm going to need a pointer to some of these objects I have over here on the side, so I could use them to display something. So let me make another structure to make things neat. Private struct child objects, all the different child objects, okay? And if we take a look at the screen here, we have bottom, start, line cursor, pause, and camera. So, okay, the bottom was a game object, so public game object bottom, that object, because we want to control the size of it to fit the whole wave. Public game object start, so we can move the start to the beginning of the bottom object, not in the middle. And then we want to have public line renderer line, because this object right here, the line that we're going to use to draw it, that's the line renderer right there. So we have a pointer to that. And then what else do we need? We're not doing it right now, but the cursor, this is the parent. And if I move the cursor left and right, then the pause and the camera will move. See, so the camera will move up and down with the cursor. So I need a pointer to the cursor. So let's see, the cursor is a game object, cursor. And let me get a pointer to the camera because that's going to be how I control zooming. Camera, cam. Okay, so that should reference all these child objects of my song. So now I could have a variable here, private child objects, and I'll just be obj, okay? So I need to initialize those child objects before I use them. Perhaps I could do it here. Next thing. Well, I should make a function to get each child object based on the transform. So let me just make a little helper function down here. Private game object, it'll return a game object and it'll give me the get the child. So I could just specify the name of the child and what the parent is. Okay, and then in here I could loop through for each transform child and parent that loops through all the children of the parent. I will see if the parent dot name dot to lower equals the name to lower. Now, the reason I'm putting the to lower on is so I don't have to worry about the case of whatever the names are. So if the names are equal, then I want to return this, wait a minute, did I say parent? This is the child when I'm looping, child. Sorry guys. I'm looping through the parent, all the children. So if this child's name equals the name that the person wants, then I'll return child dot game object. Yeah, I'll return the game object of that child. See? Now if I go through the whole loop and it never finds anything, then I'll return nothing, null. And now that should go away. So now over here when I'm looking for children, like object.bottom equals get the child. The name of it in the scene is bottom. So I'll say bottom. And the parent of it is, it's the game object that the script is. So this dot transform. That should get me the bottom. And now the next one is start, which is also a parent of the main game object. Equals get the child. It's called start. And this dot transform. And now after start, what do we have? The line, which is a child of start. So here's where this function helps me out. Object.line equals get the child line. Now I'll use the start transform because that's the parent. And I think, oh, but there's a squiggly line. Why? Because line is a line renderer and this returns a game object. That's okay because from the line object, I could get the component line renderer. So I'll say dot line, dot get component line renderer. Boom. Now I have that. And then the other thing in line render after the start is the cursor. So cursor equals get the child cursor, comma, object.start.transform dot get component. Ooh, and that is just the game object, so that's fine. And then the last thing that I had in my child objects was the camera right there. Okay, and camera is a child of cursor. So object dot camera cam equals get the child camera, comma, object dot cursor dot transform. So is it called camera? Let me just see. It is camera. I named it camera, and this has a squiggly underline because this returns a game object, but this is a camera. But just like I did with the other thing here, I just want that component right there, so I could use get component. So I'll say dot get component camera. Boom. Too many. All right, so now I got all my child objects. I have my song samples and point array. Now I want to use the point array to display the line. So object.line will, I have to set the positions, how many positions in the line. So it's going to equal song.point.count. Okay. And then object.line dot set the positions is going to equal the song, all the song points, but it's going to equal the vector 3's of the song points because the vector 3's from song point actually have the positions in the 3D game space. So how do I get just the position 3's? I'm going to use just as link lambda, whoopsie, lambda, okay, expression. So what that does is link, it enables me to kind of like query or ask from the collection for something that I want. So song.point dot select. So the select thing is part of the link lambda. And now what it wants is x, where x dot vec3 is what I want to get from it. Okay. And the set positions, it wants an array. So this is returning an IEnumerable, but there's a method on IEnumerable called toArray to convert it to an array for me. And all the squiggly should go away. There we go. So yeah, I just put this little comment here because the select is a link lambda expression thing. So if you didn't add, if you don't see select when you press dot, just make sure you add the system.link thing, okay? Then on your collections and arrays, you'll have link that you could query like this. So this will give me just the vector 3's from my point array to set the positions of the line. So we got a lot of stuff here. Let's see what it looks like now when I run the script again. So I'm going to come back here and come to the song. Let me just do a save. Now I'm going to press play. So I should hear music and see something. And I don't. But there's something to help me know what's wrong. Like right here, this is telling me there's an error. So let me click on it and then click right here. It takes me to the line of the error. So here where I did a song point add, the error says that it's null reference. Okay, before I started to put things in the song, I did not the song.point. See here, I made song.point, but it doesn't equal anything. I didn't like allocate memory for song point. So I will just do that right here. Song.point equals a new list. There we go. Now there's something else I could do because this is going to be adding in a lot of points to the list. And for each point that it adds, it's going to allocate memory for the array on the computer. But if I want all the memory to kind of be allocated nicely and together in memory.capacity, I could kind of do this, set the capacity of the array, and then when it's looping through adding points, the memory is already allocated and it just puts a point in that position. So I'm going to use capacity to set the capacity, the size of this array. And the size, how big should it be? It should be song.samples.length and probably divided by samples per point, right? Because that's how many we have. We're going to have about that many. And then I'll just say +1 for good measure. All right, so now that should get rid of the null, since right here I allocate for song before I add to it. Let's try it again now. Let's go back, make sure I saved. Okay, there's no star there. Go back over here and let the script be processed by Unity. Now I press play. And let's see what happens. I get another error. It's okay, error banera, we get through it. So let's see what this error is on line 78, that the index was outside of the bounds of the array. Okay, well, I did put this here, songsamples.length, but the length, say if your array has no elements, the length will be 0. If the array has one element, then the array, the first element is 0, not 1. So over here with the length, I just have to subtract by 1. That's my last position. And I kind of call that an off by 1 error when you get those. I call those off by 1s. I forget to subtract the 1. So that should get rid of that error. Let's see if I go back now and processing the script. Press play. There we go. So now it's displayed the wave file using the line object. And this is the game view. If I go to the scene view, you can see that, oops, my line starts displaying right here from the middle and it goes off. And how big is that? I think this is much bigger than the actual white line. So now it comes into play where I'm going to set the white line big enough to hold the whole song. So here I set the line, which is like showing the waveform. Here I got my objects. Here I set the line. Now what I want to do is I want to set the bottom. So object.bottom.transform.local scale. Now I'm going to use local for all these transforms because since they're child objects, I want to use local just to set the child. So local scale equals new vector 3. Now how long does that bottom have to be? It has to be long enough to show every song point. So song point dot count. And then I could leave the height and the depth in Z the same as they were. So I'll just feed it back in the same values that are there already. Transform.local scale.y and then object bottom.transform.local scale.z. So those will just stay the same as they were in the designer. But I changed the length. And then the other thing I want to start, I want it to move. So I'm going to change the local position. There it goes. Equals new vector 3. And the position, I want it to equal basically the object.bottom.transform local scale x times, I only want half the width and I want it to go backwards. So backwards is minus, then half the width is 0.5. And then the other two positions, I'll just take whatever the positions were in the game from the scene window. So object.start.transform.local position.x. Y. And then the same thing for z. Object.start.transform.local position.z. Boom, boom, boom. Did I put a little... Oh, it's missing that little semicolon at the end there. Okay, so that's those two things. So now that should set the bottoms thing. The start should be in the right position. Let's see what happens now if I press play, that this bar becomes big enough, and then the little start button thing in here, it should go to the start of the button. So I press play, and good. It went right here to the start. See? And the white bar is long enough to hold the song, and this went right to the start. Good, good, good. Now let's make the position thing move with playback. And this will be the last thing I do in this video for displaying and playing back. And then in the next video, we'll continue. So here, private void update. So how do we know where current position is going to be. So song.cp is going to equal, we're going to have a variable here called the time sample, like what sample is the song currently up to in playback, and we get that from here, audio clip, audio.time samples. That's the current position, right? So I don't even really need a variable. That'll just make the loop go slower. So here I'm going to have song.point, and I'm going to use the link stuff again. So when I put the dot, there should be something called where. Okay, there we go, where. So now I'm going to get all the position, all the point values where x, where the x dot start sample. Yeah, I think it's the start sample. All right, yeah, I think I do need this here. Float time sample is going to equal all dot time samples, but since samples are in mono or stereo, I got to take into account this channels. But do I multiply, or I think I multiply? Okay, so that's a time sample. So I need x where the start sample is less than or equal to time sample, and where the end sample is greater than the time sample. Okay, so it's not where. There should be one value that this returns. So I'll use the single point where this is true. I should get that point back, and that's song CP. Okay, now I'll use the object.cursor.transform.local position will equal song.vec3. Okay, song dot, why is it? Oh no, not song vec3. My point, song.cp.vec3. Okay, and that'll put the cursor in the right position. Ooh. So let's see, we just had this update with these 3 lines. Let's see if now the cursor moves with the song. Press play. It is moving with the song. That's great. So let's see. This is something where I'm not really going to be looking at it in 3D. I want to just really see it flat on. So what I'm going to do is I'm going to select the camera now, and I'm going to change it from perspective to an orthographic camera. See? So I'll just view it straight on. And now the size property I could use to zoom in and out. The other thing is I don't really want the skybox. So I'm going to change the background to just a solid color blue. Orthographics there. And here I could set the zoom level like that. Let's see if it's like 20. Okay. So that's going to be the camera I'm going to use. Let's see how that looks now. Press play. Oh, kind of a cool side effect. This thing's going up and down with the points because my vector 3 points were the actual values in the Y position. So how about if I want this position thing just to go straight along, I'll have to make another vector 3 where it's just moving straight along for my point data. So in my point data, I had the vector 3 that goes up and down with the value. I'll just add another component to my vector 3, another member variable, vec3. I'll call it straight, vec3 straight. So when I was reading and making my vector 3s over here, this one paid attention to the value to go up and down, but the one for the position, it's just going to go along the line straight. So this, I just take out the value there and put it to 0. Okay, so let's see now if it goes straight along the line. What the? Now I don't even have the waveform showing. Oh, I said vector 3 here. Vec3 straight. There we go. You guys saw that. Why didn't you tell me? All right, now I press play. All right, I got the vec3 straight, but I got to use it too. So now in the update, here it's saying it's a vec3. Now I'll set it to vec3 straight. Vec3 straight. Okay. I guess I could leave it as vec3 if I want it to go up and down. But if I don't want it to go up and down, I want it to go straight, then I could use this. Here we go. All right, cool. Now, oh, yeah, this video is kind of long. If I could just add 2 more things. I think I'll do it in the next video. I'll add in the zooming in and out. And you see the way the waveform was displaying with the white line in the middle? What I'll do is I'll show us how we could display with the waveform all on the top so that this could be the bottom value. All right, I'll do that in the next video.